Alright, now let's do question number 5. So here we have two algebraic fractions which we have to subtract. So we notice that both of them contain b, so that means b is definitely going to be part of our LCM. And then one of them has 4b and the other has 6b. So that means what we'll have to do is we'll have to take out the LCM of 4 and 6. So we start by dividing by 2. So 2 2s are 4, 2 3s are 6, and then we're going to divide by 2 again. 2 1s are 2, 3 as it is, and then divide by 3 again. So 1 1. So the LCM is going to be 2 times 2 times 3, which is equal to 12. So the LCM is 12b. Now in order to turn 4b into 12b, we'll have to times it by 3. That means we'll have to times the numerator by 3 as well. So that's going to give us 9a. And then in order to turn 6b into 12b, we're going to have to times it by 2. So we're going to have to multiply the numerator by 2 as well. So that's going to be 2a. And then we have a minus in between. So 9a minus 2a is going to be 7a upon 12b. So there you go. That's her answer, 7a upon 12b. Okay, now we have part 2. So before we can solve part 2, it will be ideal to factorize b square minus 9. So since we have two squares with a minus sign in between, this can be written as a square minus b square, where a is equal to b and b is 9. So we're going to write this as b plus 3 times b minus 3 upon 6 multiplied by 2 over b minus 3. So we're going to cancel out whatever we can cancel out. So b minus 3 and b minus 3 gets cancelled out, and 2 1s are 2, 2 3s are 6. So this is going to become b plus 3 upon 3, and this right here is going to be our final answer. Now remember not to cancel out these three, because these two, sorry, because they have a plus sign in between. Okay, now we have an equation to solve. So we leave the left side as it is, since there's nothing that can be done here. On the right hand side, however, we're going to have minus 5x minus 20. So let's bring 5x on the left hand side. So that's going to add into 3x. So 3x plus 5x is going to become 8x. And then 1 minus 20 is going to become minus 19. Yep. So x is equals to minus 19 upon 8. So there you have it. X is equals to minus 19 upon 8. Okay, now we come to part C. Okay, let's read the question here. It says a rectangular card has dimensions 2y by y plus 3 centimeter. The square of side y centimeter is cut from this rectangle. So that means this right here is a square with dimensions y by y. And the card remaining shown shaded in the diagram has area 55 centimeters square. So this, by the looks of it, has got to deal with a quadratic equation. Okay. Form an equation in y and solve it to find the dimensions of the rectangular card. Show all your workings. So that means we have to find out the dimensions of the rectangular card, which means y by 3 and 2y. So we can't do this unless we have the value of y. Okay, so we're going to use this piece of information here in order to figure out the value of y. Basically, in order to obtain an equation, and then use that equation in order to obtain a value of y. So theoretically, what we'll have to do is we'll have to take the area of rectangle, and from it we'll have to minus the area of the square, and that's going to give us the shaded area. Okay, so if I want to find out the area of rectangle, I'll simply multiply the length by width. So 2y multiplied by y plus 3, and from it I'll subtract the area of a square, which is simply going to be y squared, and that's going to give me the shaded area, which according to the question is equal to 55. Alright, now let's simplify this. 2y into y is going to give me 2y square, and 2y into 3 is going to give me positive 6y minus y square. Let's bring 55 on the left hand side. So minus 55 equal to 0. So 2y square minus y square is going to simplify and become y square plus 6y minus 55 equals to 0. So we're looking at a quadratic equation. That means we have to come up with factors of 55 that when added will give us positive 6. So 55 can be obtained by simply minus 55, sorry. So 55 can be obtained by multiplying 11 by minus 5. So 11 by minus 5, and 11 plus minus 5 is going to give us positive 6, which is exactly what we want. Okay, now we're going to split the middle term using 11y minus 5y minus 55 as it is equals to 0. So y into y plus 11, and then we're going to factor out minus 5, y plus 11 inside equals to 0. So we have y minus 5 times y plus 11 equals to 0. Now remember, at this point, don't get carried away and think that y is equals to 5 or y equals to minus 11 is going to be our final answer. By the way, in these two values, we're not going to accept both the values. We're going to accept one and we're going to reject the other. And the reason for that is because one value is positive and the other is negative. And since y is representing lengths, we can't have a negative length. So y equals to 5 is our final answer. So we're going to use this value of y, which is 5, in order to obtain what y plus 3 is. So y plus 3 is going to be 5 plus 3, and that's going to be equal to 8. And 2y plus 3 means that 2 into 5, which is going to be equal to 10. So 8 and 10 are our final answers. Alright, now let's do question number 7, where we will have to first of all fill this table. And when filling this table, we'll have to fill it correct to 2 decimal places as it is mentioned in the question. So here the y is equals to 1 plus 2 upon x. So if I want to find out the value of y, that means I'm simply going to plug in 8 in place of x. So let's do that and see what the value of y is equals to. So 1 plus 2 upon 8. So that's equal to 1.25. Okay. Now I'll have to draw the graph. So we'll one by one plot the points and make a graph out of it. So 0.5 comma 5, so that shouldn't be too difficult. So there you have it. Remember to put a cross and not a dot. 1 comma 3 is again going to be somewhere here. 2 2, pretty simple, it's going to be here. And then we have 3, 1.67. So 1.67 has got to be between 1.6 and 1.7. So let's mark it here somewhere. 4, 1.5, again very easy to mark. 4, 1.5, there you go. 5, 1.4, so there we have it. 6, 1.33, so I'll have to log this at 1.3. 1.1, 2, 3, there you go. 7, 1.29, so this I'll have to lock it at 1.3 again. So 7, 1.3, 1, 2, 3, there you go. 8, 1.25, so this I'll try and mark between 1.2 and 1.3. So here we have 1, 1.1, 1.2, 1.3, so just like half a box below the previous point. Okay, so now we're gonna join them and make a smooth curve out of it. Let's use the color green. Okay, so here we go. So far so good. And well, this can be slightly better. There you go. So that's our curve plotted. Okay, the next question says the line L crosses the graph of y equals to 1 plus 2x at x equals to 2 and x equals to 5. Find the equation of line L. Okay, so here I just have the x values, and if I want to figure out what the y values are, that means I'll have to take these values of x and plug them in the equation. So y is equals to 1 plus 2 upon 2. So that's going to give me y is equals to 1 plus 1, which is equal to 2. That means one point is going to be 2 comma 2. Let's find out the y coordinate of the other point, for which I'll have to plug in 5 in place of x. So 2 upon 5 is 0.4. So y is equals to 1 plus 0.4. So that's going to be 1.4. So the other point is going to be 5 comma 1.4. So I'm going to find the equation of this line. That means I'll have to find the gradient and the y-intercept. So let's find out the gradient first. 1.4 minus 2 over 5 minus 2. So that's going to be equal to, actually let's just use a calculator to be sure. 1.4 minus 2 divided by 5 minus 2. So that's equal to minus 1 over 5. So far my equation looks like this. Y equals to minus 1 upon 5x plus c. Now let's find out the value of c by, I'm going to plug in this point 5 comma 1.4 so that the x can get cancelled out. 1.4 is equals to minus 1 upon 5 in place of x plus c. So this gets cancelled out, and 1.4 is equals to minus 1 plus c, and c is equals to 2.4. So the equation is y is equals to minus 1 upon 5x, and actually let's figure out the fractional value of 2.4. So 2.4, that's equal to 12 upon 5 plus 12 upon 5. So this is the equation that will of line L, which will cut the graph or cross the graph at x equals to 2 and x equals to 5. Okay, now in part D we have to draw a line with gradient minus 1 over 3, and this line crosses the graph of y equals to 1 plus 2 upon x when x equals to 1 and x equals to k. and by drawing a suitable line we have to figure out the value of k. Okay, so in order to plot a line we need a gradient, which is what we have, and we need a point through which the line is passing. So the gradient is -1/3, and if I want to figure out what the point, if I want to figure out the coordinates at which it is passing from, so I have the x coordinate, I need to use the x coordinate in order to figure out the y coordinate. So I'm going to take this x coordinate and plug it in this equation in place of x. So y is equals to 1 plus 2 upon 1. So y is equals to 1 plus 2, which is equal to 3. So that means the point through which the line is passing is going to be 1 comma 3. So I'm going to use this information in order to find the equation. So y is equals to -1/3x plus c. In order to find c, I'll plug in the value of x and y. So 3 in place of y and 1 in place of x plus c as it is. So c is going to be equal to 3 plus 1/3. So that's going to be equal to 3 whole 1/3, or simply 10 upon 3. Okay, so this is not very useful so far because I need to plot this line, and once I've plotted this line I need to find out what the value of k is. So I'm going to plug in a couple of points. So I'm going to take -1/3x plus 10/3. So I'm going to start off by plugging, I'm not going to plug in 0 because that will just leave me with the value, that'll just leave me with decimal. So instead I'm going to plug in 1 in place of x. So if I plug in 1, I know that the value of y we just saw is going to be equal to 3. So I need another x value which is going to give me y as an integer. So I'm going to do a bit of trial and error. So I'm going to try and plug in 2 and let's see what that gives me. So if I plug in 2, so actually first I'll rewrite this equation as -x plus 10 upon 3. So if I plug in 2, that's going to be -2 plus 10 upon 3. That's not going to give me an integer. So let's try 3. 3 is also not going to give me an integer. 4, however, will give me an integer. So -4 plus 10 is going to be 6. 6 upon 3 is going to give me 2. So although ideally we need 3 points in order to draw a straight line, but 2 are also enough. So the 2 points I have are 1 comma 3 and 4 comma 2. So let's mark these 2 points, 1 comma 3 and 4 comma 2, on our graph. So 1 comma 3 is going to be here and 4 comma 2 is going to be here. So I'm going to join these 2 points with the help of a straight line, and obviously I'm going to extend my line to see where it goes. So here we have it, and we can see that this line is crossing the curve at 2 different points, and these 2 points, one of these 2 points is the x coordinate of one of these 2 points is 1 and the x coordinate of the other point is 6, and that's exactly what the question wanted us to find out. So 1 was already given and we had to find the value of k using a straight line. So k is equals to 6. Now let's move forward. Let's do question number 8. So we have data which is in interval form, and let's see what the question says. The mass in grams of each of 75 oranges is measured. The results are summarized in the table. Okay, one of these oranges is chosen at random. Find the probability it has a mass greater than 200 grams. Alright, so greater than 200 grams means this category is greater than 200 and this category is also greater than 200. So that makes it a total of 18 plus 5, which is 23 out of 75. This cannot be simplified any further, so 23 upon 75 is going to be our final answer. Calculate an estimate of the mean marked. Okay, so whenever you have data which is in range form and you have to calculate the mean, so one thing that we all have to calculate is the midpoint of every range. So 160 to 170, the midpoint is going to be 165, range or interval, whatever you like to call it. 170 to 180 is going to be 175, 180 to 190 is going to be 185, and then 195, 205, 215. Now I'll have to multiply all these values by the frequency. So 165 multiplied by its respective frequency plus 175 multiplied by 10 plus 185 multiplied by 15 plus 195 multiplied by 23 plus 205 multiplied by 18 plus 215 multiplied by 5. Once you've done this, make sure that you divide this by the total frequency, which according to the question is equal to 75. So I'm going to punch this in my calculator as it is, and I'm going to get what the answer is. So the answer to this, correct to 3 significant figures, is going to be 192. Remember, this answer is correct to 3 significant figures. Okay, now on the grid on the next page, draw a cumulative frequency diagram for the mass of the oranges. Okay, so when you have to plot the cumulative frequency diagram, what we have to do is we have to add all the frequencies up. Okay, so for as long as 170 is concerned, the corresponding frequency for 170 is going to be 4. So that means one point is going to be 170 comma 4. So 170 and 4 is going to be somewhere here. And then we have 180. So all the number of oranges whose mass happens to be less than 180 is going to be these 10 along with these 4. So that's equal to 14. So we have another point which is 180 comma 14. So let's mark that. 180 comma 14 is going to be here. Okay, and then 190. So for that we'll add 15 and 14 together. So we're going to get 29. So we have another point which is 190 comma 29. So let's mark that. There you go. And then 200 comma 23. So let's see, what's 23 plus 29, that's equal to 52. So 200 comma 52 is another point. 200 comma 52, there you go. And then we have 210, and in it we're going to add 18. Let me just erase this. Yeah, so 52 plus 18 is going to be 70. So 210 comma 70 is another point. 210 comma 70, and then at 220 it is going to be equal to the total frequency, which is 75. So 220 comma 75 is going to be somewhere here. Okay, now once you have marked all the points, remember to join them with the help of a smooth curve. So I'm going to do just that. So there you go. There you go. Now let's see if there's a following part. Yeah, C part is done. Okay, now we have to use our graph to find an estimate for the median. So what's median? Median is basically 50% of the total frequency, which is 75. So 50% of 75, let's see what's that going to be equal to. That's going to be equal to 37.5. So we're going to try and be as close as possible to the original value and see what the answer is. So this is going to be 35, this is going to be 37, this is going to be 38. So 37.5 is going to be between 37 and 38, of course. So the corresponding value is going to be somewhere, let's see. Well, my answer is 193, but then again there is going to be an acceptable range, and 193 they will definitely fall in the acceptable range. Okay, now let's do part E, which says oranges with a mass of more than t grams are labeled as class A. 20% of the oranges are labeled class A. Okay, now the question says use your graph to find t. So 20% of the oranges are labeled class A. So let's find out what 20% of the total frequency is equal to. So 20% of 75 is got to be equal to 15. So that means 15 such oranges are labeled class A. And what do we have to find out? We have to find out the value of t, which is basically representing the grams. So what I'm going to do is I'm going to count backwards, and I'll tell you what I mean by backwards. I'm going to start from the top, and you can see that this ends at 75. So the top 15 are going to be classified as class A, and they're going to have a mass which is greater than a certain value, and that value is t grams. So that means they're going to start from 60 and end at 75, since the quantity is equal to 15. So I'm going to start from 60, see what the corresponding value of 60 is, and that value is going to be my answer. So here we are. Let's come down and see what the value is. So this value is equal to, let's see, this is going to be 201, 2, 3, 4. So this is equal to 204 grams. So that's what the value of t is equals to. Okay, now the question says oranges with a mass of 178 grams or less are used to make orange juice. Use your graph to find an estimate for the number of oranges that are used to make orange juice. So I'm going to look at 178 on the x-axis and see what the corresponding y value is. So let's switch to a different color. So 178 is going to be here. So I'm going to start from here, go all the way to the top. Actually, not all the way, but till I reach the cumulative frequency curve. And then I'm going to turn left. So this is equal to 12. So that means out of these 75, only 12 are suitable to make orange juice. So that's what my answer is going to be. And the reason why I chose 12 and I did not subtract 12 from the total frequency is because the question said 178 grams or less. So we can see that this right here is basically the number of oranges that are either 178 grams or less. Had it been more than 178, so what we would have done is we would have taken 12 and subtracted it from 75. So that was question number 8. Now let's do question number 9. So we have a triangular prism, and ABC we can see is a triangle, and we have to calculate AB. So right away we can see that we have two sides and an included angle, and when that happens to be the case and you have to calculate the missing length, we do so by using cosine rule. So AB square is going to be equal to 15 square plus 14 squared minus 2 times 15 times 14 cos 27. So I'm going to do this in my calculator and let's see what the answer is. So AB is going to be equal to 15 squared plus 14 squared minus 2 into 15 into 14 into cos 27. So this is equal to 46 point something, and then I'm going to square root this answer. So that's equal to 6.84 centimeter. Correct to 3 significant figures. So 6.84 is going to be my final answer. There you go. Okay, now the question says the length of the prism is p centimeter and the volume of the prism is 1000 centimeter cube. Calculate p. Okay, so how do you calculate the volume of a prism? Volume of a prism, or any uniform solid for that matter, can be calculated by taking the area of cross section and multiplying it by the length. So if I want to calculate the area of cross section, that means I'll have to calculate the area of this triangle. So calculating the area of this triangle can be done by using the sine formula, since we have two sides and an included length. So half into 15 times 14, the two lengths, multiplied by sine of the angle that's in between two lengths, which we can see is 27. So multiplied by sine 27, multiplied by the length, which according to the question is p. This should give us the volume, which again according to the question is equal to 1000. So I'm going to solve this for the value of p. That means 1000 will be divided by the area of cross section, which is half times 15 times 14 times sine 27. So I'm going to write this as it is in my calculator and press equals to. So the value of p will turn out to be 20.98, which correct to 3 significant figures is going to be equal to 21.0. So 21.0 is going to be my final answer. Okay, now we do part C, which says the prism is to be packed in a carton. The carton is a cuboid of size 15 centimeter by p centimeter by h centimeter. Calculate the smallest possible value of h. Alright, so you got to make sure that you can conveniently place this prism inside a cuboid. So the smallest possible value of h is got to be the height of this prism. So you got to make sure that the size of the height of the cuboid is at least equal to the size the height of the prism. Okay, so now what I'm going to do is I'm going to calculate this height first and see what is this equal to, and then once I've calculated this height, then I'm going to assume that this right here is my base, and I'm going to calculate this height, this one, the one that I've highlighted in blue. Whichever one turns out to be the smaller one is going to be the smallest height. So we start off with calculating the green one, and in order to calculate the height in green, I'm going to have to use this triangle in which my hypotenuse is 14. The angle provided is going to be 27, and this obviously is going to be a right angle, and I have to calculate the length opposite of 27. So we can do this by using sine here. So sine 27 is equals to, actually let me just call this h1, height 1 upon 14. So height 1 is going to be equal to sine 27 multiplied by 14. So let's work that out. Sine 27 multiplied by 14 is going to be equal to 6.35 or 6.36, actually, correct to 3 significant figures. Okay, now let's calculate the height that I've marked in blue. Remember, this angle is also going to be a right angle. So if I were to draw this nicely, my hypotenuse is going to be 15, the angle is going to be 27, and this is the height that I have to calculate. I'm going to call this h2. So actually right away I know that this answer is going to be greater than 6.36 because the angle is the same, but the hypotenuse length is 15, which is greater than 14. So that means there's no point in calculating this. So 6.36 is going to be the smallest possible height. So I'm just going to write that 6.36. Remember, whatever we did here is supposed to be done in the answer space that's provided here. Okay, so in question number 10, the first part we have to find g minus 2f. So this means that 1, negative 5 minus twice of 4 and minus 3. So this will become 1 minus 5, and multiplying both the values by 2 will give us 8 and minus 6. So 1 minus 8 is going to be minus 7, and minus 5 minus minus 6 is going to turn into positive 1. Next part, the question says Petra writes that the magnitude of f is greater than the magnitude of g. Show that Petra is wrong. Okay, so if I find out the magnitude of f, that's going to be 4 squared minus 3 squared minus 3 whole squared, and the magnitude of g is going to be equal to 1 plus minus 5 the whole thing square. So we don't have to take out the square root. We can see that this is going to be square root of 25, and this is going to be square root of 26. So that is clearly not the case, and that is why Petra happens to be wrong. So you get 3 marks for this. Now we come to part B, and this is again a vectors related part in which we have O, A and B are points with OA being A and OB being B. P is the point on OA such that OP is equals to 1/3 of OA. So since OA is equal to A, OP is going to be equal to 1/3 of A, and PA is going to be the remaining part, which is going to be 2/3 of A. Now OQ and R lie on a straight line, and QR is the midpoint of PB, and we have to calculate what PB is equals to. So if we start from P, and if we want to end up at B, so we're going to go from P to O first, and then from O to P. So P to O is going to be minus 1/3 of A, and then O to B is going to be positive B. So we have PB, and that is minus 1/3 of A plus B. Okay, in the next part the question says that find OQ in terms of A and B. So OQ means that we're going to have to go from O to P and then from P to Q. Now we don't have what PQ is, but we know that Q is the midpoint of PB. So that means once we have PB, which is something that we've already calculated in part 1, we're just going to divide it by 2. So O to P is 1/3 of A positive, and then P to Q is going to be half of PB, which is going to be half of minus 1/3 of A plus B. So this is going to be 1/3 of A minus 1/6 of A plus half of B. So 1/3 of A minus 1/6 of A is going to give us 1/6 of A plus half B as it is. In the next part, we have the question tells us that QR is equal to twice of OQ. So let's figure out what QR is right away. QR is going to be equal to twice of 1/6 of A plus half B. So this is going to be twice into 1/6 is going to give us 1/3 of A, and half into 2 is going to give us B. So this is what QR is equal to. And we have to show that AR is parallel to PB. So we already have what PB is equal to. Okay, so let's just write that here again. So PB is equals to minus 1/3 of A plus B. Now we have to show that AR is parallel to PB. Okay, so let's try and figure out what AR is equal to. So if I want to figure out what AR is equals to, that means I'll have to go from A to O and then from O to R. Now I don't have what OR is equals to, but I have OQ and I also have OR. So I can use these two in order to figure out what AR is equals to. So let's do that again. A to O is going to be minus A. So let's write that. Oops, sorry. So remember, we're trying to figure out AR. So A to O is going to be minus A plus, we're going to go from O to Q. So O to Q we figured, and it's right over here, and that is 1/6 of A plus half B. So 1/6 of A plus half b, and then plus qr. So qr is something again that we have figured, and that is equal to qr. Yeah, so we figured what qr is equals to. Qr is equals to 1/3 of a plus b. So let's simplify this and see what do we get. So here's what I'll have to do: minus a plus 1/6 of a plus 1/3 of a. So minus 1 plus 1 upon 6 plus 1 upon 3. So I'm just adding the coefficients of a. So this gives me minus half a, and I have a half b and b. So half plus 1. So this is going to give me 3 upon 2b. So this is what AR is equal to. Now if I want to show that AR is parallel to PB, so let me just write PB here again. So PB is minus 1/3 of A plus B. So that means I'll have to take out the ratio of the coefficients and show that the ratio of the coefficients of A is equal to the ratio of the coefficients of B. So taking the coefficient of A from AR is going to give me minus 1 upon 2, and taking the coefficient of A from PB is going to give me minus 1 upon 3. This I need to show is equal to 3 upon 2 over 1, and these are basically the coefficients of B from AR and PB respectively. So first of all, these two get cancelled out, and half divided by 1 upon 3 basically means 3 upon 2, and 3 upon 2 divided by 1 is also equal to 3 upon 2. So here we have proven that yes, we have shown actually that AR is in fact parallel to PB. Okay, now we move to the last question, which is question number 11, and this is a fairly easy question. We have to find g of 2. That means I'm going to plug in 2 in place of x in the function g. So 7 into 2 upon 4 minus 1. Since this is paper 1, I can do this in a calculator. 7 times 2 is 14. 14 divided by 4 minus 1. So that's equal to 5 upon 2. Now we have to find g inverse of x. Let's see. The first step is we'll have to replace the whole function with y and then make x the subject. So y plus 1 equals to 7 upon 4x. Let's cross multiply. So we have 4y plus 4 equals to 7x. Now let's make x the subject. We're just one step away. Actually 2 steps. So x equals to 4y plus 4 upon 7. Now the final answer, we'll have to replace y with x. So it's going to be 4x plus 4 upon 7. Okay, now the question says that given that f of t equals to 6, find t. So we're going to replace x with t and set it equal to 6. So 3 into t minus 2 is equals to 6. So t minus 2 is going to be equal to 6 upon 3, which is equal to 2. So t is equals to 4, and there we have the value of t. Okay, now the question says that f of 7 upon 4x minus 1, or 7x upon 4 minus 1 is equals to px plus q. Find p and q. Okay, so in what we're going to do here is that in place of x in function f, we're going to replace 7x upon 4 minus 1. So the first thing I'll have to do is I should expand these brackets. So f of x is equals to 3x minus 6. Now in place of x, I'm going to write 7 upon 4x minus 1. So let's see what is that equal to. So f of 7 upon 4x minus 1 is going to be equal to 3 into 7 upon 4x minus 1 and minus 6 as it is. So let's see. So 3 into 7 is 21. 21 upon 4x minus 3 minus 6. So we can further simplify this. 21 upon 4 will remain as it is. Minus 3 minus 6, however, is going to become minus 9. So according to the question, this should have been equal to px plus q. So let's see what the value of p is, and let's see what the value of q is. So if I compare, I can see that the coefficient of x is representing p, which is equal to 21 upon 4, and the constant is equal to minus 9. So here I have the values of p and q, and with this we have solved the paper of May-June 2019, and this is paper 2 and variant 2. I'll see you guys in the next video with another past paper. Until then, take care. Bye bye.